Welcome everyone to yet another exciting week of science news. Today we'll talk about why Mars glows green, an amazingly cool way to make magnets hover, a study which found that a supposed piece of alien tech isn't alien tech, which surprised absolutely no one, plans to use the entire moon as a gravitational wave detector, progress with D-Wave's quantum computer, why Saturn's rings will temporarily become invisible, wires that learn, energy from indoor lights, and of course, the telephone whirring. The European Space Agency has found that planet Mars is glowing green, and a group of astrophysicists says they know why. The data come from the ExoMars Trace Gas Orbiter. The orbiter already detected a few green flickers in the atmosphere of Mars in 2020, but now they have more details. It turns out that the green glow is strong enough to be visible both from the planet's surface and from above the atmosphere. A group of astrophysicists looked at the data and just published a paper about this. They studied the spectral composition of the light and say that the glow comes about like this. Mars's atmosphere is thin and mostly made of carbon dioxide. At about 70 kilometers altitude, the sunlight is strong enough to split the carbon dioxide into one carbon and two oxygen atoms. The strong winds on Mars carry the oxygen atoms to the dark side, where they recombine. The recombination mostly releases infrared light, which was measured already in 2012, but in the new paper they say it also creates the green glow. It's a completely different effect than the aurora that we have on Earth. That light show is created when charged particles from the sun hit the atmosphere. They kick some electrons into higher atomic energy orbitals. When the electrons drop back down, they release energy in the form of light. This happens for different atoms and different orbitals, which is why the aurora can have several different colors. The Earth does have atmospheric glow too, but it's not visible from the surface. It's called an air glow or night glow and also comes mostly from molecular recombination. Since Earth's atmosphere is more complicated than that of Mars, on Earth the night glow actually has different colors at different altitudes. Well, that was interesting. If you'd asked me yesterday, I'd have guessed night glow is a makeup line, and air glow is that smug grin on the faces of people who fly first class. Researchers from the Technical University of Denmark have found a way to make a magnet hover in the air. By spinning one magnet at high speed, they've picked up a second magnet, which then rotates and hovers at a set distance from the first magnet. It's all standard physics, but just wasn't known until someone discovered the phenomenon 2 years ago. In the new paper, they now investigated this effect further and also explained the physics behind it. They found that the magnet that was picked up by the spinning magnet was basically racing to align itself with its spinning acquaintance, forcing it to also spin. And once it got spinning, the picked up magnet was locked in position by its rotation. It would only stop spinning when the rotational energy decreased, allowing the magnetic forces to trump the spinning action. As I keep saying, physics is basically magic. Two astrophysicists from Arizona State University appear to be unhappy with one of their colleagues, the Harvard astronomer Avi Loeb, and they add their disapproval in a recent preprint. Loeb is the guy who claimed a few years ago that an asteroid that passed through our solar system was alien technology. He then continued to make headlines with a variety of outlandish claims. His most recent attention grabber is that an object that struck the Earth in 2014 was of interstellar origin, so not from within our solar system, but from much further away. He supposedly proved this by trawling the ocean floor near where the object was projected to have fallen just north of Papua New Guinea. There he claims to have found 9 metallic spherical objects called spherules. He says they must have come from interstellar space because of their supposedly unique chemical composition that differs from that of meteorites from within our solar system. Oh yes, and he says the spherules might be evidence of alien technology because they contained beryllium, lanthanum and uranium. In the new paper now, the two astrophysicists from Arizona refute Loeb's claims. They say that the composition of meteorites changes when they're in water for a long time because some minerals get washed out and others not. They show that meteorites found in the Indian Ocean indeed are very similar to the supposed alien tech. They also check the ion composition of the spherules and say they're perfectly compatible with that of objects from within the solar system. They conclude that the spherules are almost certainly not of interstellar origin. Another recent paper supports this by saying the spherules were likely contaminated by human-caused pollution, such as coal ash. In a nutshell, I'm not sure what this is, therefore its alien tech is not exactly a masterwork of logical deduction. A team of researchers from Beijing Normal University have come up with a plan to measure gravitational waves by using the entire moon as a detector. Gravitational waves, aka ripples in space-time, can result from violent astrophysical events like mergers of neutron stars and black holes. These waves distort space and time, and with that the matter that sits in it. It's a tiny distortion, but if you can very accurately measure the size of something large, you can track this distortion. This is how gravitational wave interferometers like LIGO work. But gravitational waves come from many different sources and in many different frequencies. And just like telescopes, gravitational wave detectors are only sensitive in some parts of the spectrum. If one could use the entire moon as a gravitational wave detector, one could measure the frequency range of roughly 1/10 of a hertz to a hertz. That's because when a wave within that range hits the moon will resonate, which makes it easier to detect the signal. In the new paper, they propose to measure those tiny deformations of the moon with an array of very sensitive laser seismometers. One would then look for correlations between seismic events on different sites. They have worked out a design for the detectors that they say is robust and that can also be deployed by autonomous robots brought there by China's moonlanders. Such a moon detector would measure gravitational waves in a frequency part that isn't accessible to Earth-based devices and also not to pulsar timing arrays or planned space-based missions. A problem is, however, that the moon has what's called thermal quakes. Since the moon has no atmosphere, its surface warms very quickly when exposed to sunlight and then cools very quickly in the shadow. This causes the rocks to contract and expand and creates small moonquakes. It's kind of like your car engine crackles after you turn it off. For this reason, they want to put the seismometers inside craters. Any resemblances to other devices is entirely coincidental. You might have seen a few headlines recently saying that Saturn's rings will disappear in 2025. If you kept on scrolling because that seems just a bit too unbelievable, well, I looked at it and it turns out to be true. But it doesn't mean what you might have thought it means. You see, the Earth rotates on an axis that's tilted relative to the plane in which it orbits around the Sun. Our equator is tilted about 23.5 degrees relative to that plane. Saturn spins on a similarly tilted axis with its equator tilted by about 26.7 degrees. Saturn's rings now orbit the planet above its equator, so they also have that tilt. The reason that Saturn's rings are disappearing is because of this tilt and because the rings are actually extremely thin. If you look at them edge-on, you basically can't see them. It takes Saturn a bit more than 29 Earth years to go around the Sun once, and twice during this Saturnian year, we from Earth look at the rings edge-on, so they seem to disappear. Last time this happened was in 2009, and it's expected to happen twice in 2025. First in March, after which the rings will slightly come into view before disappearing again later in November. So they'll not disappear forever, just temporarily. However, Saturn's rings are expected to eventually vanish entirely because the rocks they're made of are gradually falling into the atmosphere. Estimates say they'll last something between 20 and 400 million years. I haven't lost my wedding ring either, it's just fallen into the atmosphere and evaporated. By the way, this video comes with a quiz on quizwithit.com, and we now have a ranking page so you can try to beat Mikkel's top score. A team of researchers from the University of Sydney and University of California's Los Angeles have taught new tricks to wires. Yes, wires. They built a network of silver nanowires that's able to adapt in real time when given feedback with electrical currents. Previous studies have shown that these networks have a sort of memory, but this is the first study to show that they're able to learn. They call their device a nanowire network. It's basically a physical realization of a neural network. That's a computer program which is itself modeled after the human brain. The wires respond to electrical signals kind of like neurons by strengthening some connections of wires while weakening others. The researchers demonstrated this real-time learning with a standard test for artificial intelligence. That's an image recognition test based on a collection of 60,000 single digits written in different handwriting. It's provided by the US-American National Institute of Standards and Technology. For the test, you train your system with the 60,000 images and then use another 10,000 to see how well it learned the lesson. The wire network learned to tell the digits apart with an overall accuracy of 93.4%. That's about as good as me without my contact lenses. And that box of old cables in the corner over there really doesn't think my jokes are funny. Researchers from the quantum computing company D-Wave say they've succeeded in bringing down errors in their newest device. D-Wave pursues a somewhat different approach to quantum computing than most companies. It's called quantum annealing, and it's a type of quantum simulation, so basically a way to custom design a difficult optimization problem. The idea is that properly set up, the quantum system relaxes into an optimal state that answers your question. It's kind of like settling into the most comfy position on a couch, but with quantum tunneling and entanglement. Since it's got something to do with quantum and with computing, I think it's fair to call it quantum computing, but the approach is very different from that pursued by IBM and Google and many others who try to develop what's known as a universal quantum computer that can execute algorithms. Quantum annealers have the advantage that they might get to commercially interesting applications faster, but they suffer from the same problem as all quantum computers. It's that the quantum states are very fragile and noise sensitive, which brings in errors. The duration for which quantum states maintain their quantum properties is called the coherence time. The D-Wave people now report in a new preprint that they've been able to correct some errors in their new computer and thereby effectively increase the coherence time by a factor of 10. They did it with what they call a zero-noise extrapolation. For this, you deliberately expose the quantum computer to various amounts of noise and observe the result. Then you extrapolate to zero noise. That's really clever. Hello. Hi, Elon. Yes, I'm mightily impressed you built the world's biggest rocket. Forget about space travel. Just think of it as fireworks. Keeps people on Twitter too. What more could you want? Inner peace? Have you been watching TikTok again? Elon? A group of material scientists from the Fraunhofer Institute in Freiburg, Germany, says they found a way to power smart homes by using solar panels indoors. That a home is smart doesn't mean it has a PhD. It means its devices are connected to the internet and can be controlled from a phone or computer. And while most of those devices don't take up a lot of energy, the energy to power them still needs to come from somewhere. The idea of the new paper is that you use the energy from artificial lights that's otherwise lost into oh so slightly warming up the surfaces in the room. This sounds rather obvious, I know, but the problem is that solar panels are usually optimized to work with sunlight, and artificial indoor light has a different spectrum. The researchers tested 8 different types of photovoltaic cells and found that the ones best suited for indoor lights were those made of gallium gallium indium phosphide. The good news is that they were remarkably efficient, turning about 40% of the light energy that hit them into electricity. They also retained the energy really well. The bad news is that they're also the most expensive ones. In case you wonder now why no one's thought of charging a cell phone with a lamp, it's because it'd take forever and then you'd miss the science news. Thanks for listening. We'll be back next week.